Hey, how you guys doing at Fort Worth?
Good.
How are you?
Good, doing well. Hi, Margaret. Hello.
That's good. Some. Those are the first ones.
No.
Very wide.
Yeah.
So we have like open classes. It's kind of nice. We always had to talk from lunch. We're also this.
All right, my system's acting up here. What's going on?
It is so nice outside. It's
Nice, huh? Oh, there it is. Good. Let's see. So now, Max, let's get you. Hey, Chandler.
Hello.
How's it going?
It's good.
Good. Let me back this off a little bit. Chandler, you coming in from home today?
Yes, we are. And Maurice is too. We didn't have school today.
Oh, okay, I got you. What is wrong with my camera? It's not responding.
Why didn't you have school, Chandler?
Senior skip day today. So.
Nice. Well played to be in class.
Our skip day was supposed to be today.
I know. All right, I cannot figure out why it's not doing that. This is frustrating.
What is going? Is it not
I don't know
adjusting?
what it's doing. Hi, Maya.
Hello? Hello?
Samvit, it sounds like we can hear you but can't see you yet.
Well, I'm on my phone, Mr. Walker. We discussed this.
Oh, yeah, Samvit. Thanks for the reminder, buddy. Hi, Robin. Hi, let's see. Is that Maurice? It looks like I can barely see in the corner there.
Hello, Mr. Walker.
Good to see you. Hello.
Mr. Walker, I will be muting my mic until 2:16.
All right, Samvit. Thanks, buddy.
Did you? Yeah. You can see the flicker in the blue. So like it definitely spawn. Like you see what I mean? Like look at the blue light. When I press it, it flickers. So it definitely. Oh wow.
Hi, Olivia.
You know how some look at this. Look at our screen when I press the button. Do you see that?
Oh, you can actually see the
Yeah,
color.
like
Good.
look at it like this.
Oh, nice. Samvit will be so pumped. I don't know if
see
he can
it.
hear you yet. No, I can't. But... So what, we can see it?
Yeah, look here when I press the button.
Yeah, see, they. I don't know if they
I
can
would
see
assume
that.
they can
If
see
we,
it.
yeah. All right.
Could also be because I'm pointing at the, like if I.
All right, so let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and Samvit is logged in from a bus traveling somewhere in Florida with a bunch of classmates. So you got to be impressed with him.
I am
for
in a
doing that.
Wendy's restaurant outside of Miami, eating fries on the way home.
Eating fries on the way home. Awesome. We need to start with Robin's presentation on graphene. Can you guys check the email I just sent? And it's it's on Google Drive, so we're going to make sure everybody's shared on that. Robin, do we watch that live, right? Yeah. So I'm opening it up as a loading movie on my screen. So this is what it looks like. And Max will probably watch it with me. Can I get thumbs up once people have it? Margaret's good. Olivia's good. Chandler's good. Olivia's still waiting. Maurice is good. Dallas Fort Worth is good. Fort Worth Country Day. Maya's good. Okay. Are we ready for a 3, 2, 1 countdown and we'll start? Okay, Samvit, let's see. You cannot see or you can see what's projected on your phone? Samvit? Samvit?
I guess he's no good.
Okay, I don't know where Samvit is.
Mr. Walker, I'm so hi. Hi, no, okay, there's something weird about my headphones where I guess it destroys where it mutes my mic if I plug it in. So
Yeah.
I have to keep this thing up to my ear. So I'll see what I can do. Okay.
Okay, so we're going to start Robin's presentation, and if you can't hear it, we'll be able to share it to you electronically, or you'll have it on your phone for later. So let's go ahead and start on 3, 2, 1, begin.
Hi everyone, so today I'll be presenting about graphene. But to begin with, what is graphene? Graphene was discovered at the University of Manchester in the 2000s. Firstly, graphene can be considered a single layer of carbon atoms, connected in a large network. Further, it is an allotrope that is arranged in a number of hexagons. The structure is also known as the honeycomb or chicken wire lattice, or a hexagonal wire pattern. The bond hybridization type is sp2, and I shall reference this again later. Last, the average bond energy
Whoops.
All right, nice job. I believe, Chandler, you're up for our first question for Robin, please.
Yes, you answered my first question, but my second one is, how much thinner is graphene than human hair?
I believe it is 1 million times thinner.
Yep, that's right on.
Boom! Nice, great question, and good job on the answer, Robin. Way to go. Excellent presentation. And how about some other questions from your classmates? And Casey's up next, and she's doing nanotechnology, so it's great placement. And I'm sure there'll be some things that'll relate back to what you just said in her presentation. Other folks have questions for Robin? Great, Olivia, thank you.
I was just wondering if you knew of, I don't know if you covered it, I don't think you did, but any like current applications of graphene that are being investigated?
Yeah, definitely. So one that's been developed recently is sort of a super effective light bulb that uses LEDs. So there's sort of an LED inside a graphene bulb. I think it's probably quite a bit more complex than that, but it's just super effective. And in comparison even to LEDs that Samvit, for instance, covered. So that's one of the more recent ones, but they are really looking forward to developing other technologies that use graphene, I don't know, smartphones, for instance, etc., batteries, and so
on. Max, and then Willie?
You said graphene is transparent and, or like appears to be transparent. I guess that means, so light can pass through it due to being so thin, but I'm having a hard time understanding how it's transparent, but at the same time still so strong. Like, what makes it transparent? Because there is still something there. It's just like, I don't know. I'm just blown away by that.
Yeah, well, basically, it is, of course, made of real atoms, and as a matter of fact, it is not completely transparent, but at the same time, it also just absorbs 2.3% of light in those in this really thin sheet. So I guess that if you think of, for instance, a piece of paper, I don't know, light does come through it, but not as much because it's just much more dense. Whereas graphene is so thin that much more light is able to pass. So maybe kind of like an analogy with paper.
Willie, was that a question from you? Yeah, Willie.
Just exactly how like labor intensive is the process of creating graphene? I mean, is it like simple, or like does it take a really long time to produce a massive amount of it?
Well, it really depends how much you want to produce, as you said. So the easiest way really is to just take some Scotch tape and sort of take pieces of graphite off numerous times, and that is relatively simple. But if you want to produce a great amount, I think that carbon reduction is the most effective method just to produce relatively large amounts. In comparison to, say, the Scotch tape removal sort of method. And as a consequence, it's really not being made too much yet, but it's being used definitely in universities, etc., for research. But yeah, massive amounts have not been made yet, sort of in kilograms or in such degrees.
Joel, looks like you have a question, and then Maurice.
Yeah, I was wondering if there are any, since it's so strong, if there's any possible uses of like using it in structures like, I don't know, maybe buildings or tables or something like that, not just like smartphones or other things.
Well, one issue with that sort of is also its flexibility. So if you would, for instance, use it in buildings, then the buildings would be flexible. At times that may be effective, say in places where earthquakes may affect the area, or also strong winds, etc. But it's mainly sort of been thought of being used on sort of smaller scales than that.
Maurice?
Yeah, I had a question about graphene and its relation to its semiconductor properties. How does it kind of compare to silicon or gallium oxide, something like that, or gallium nitride, excuse me?
Well, based on studies, at least, it's said to be the most conductive material known to humanity at the moment. So that sort of, it is quite a bit more conductive than silicone, etc. So that's basically sort of the comparison factor. Just it is more conductive than many other metals like copper, etc.
Yeah, just for fun, I did a quick calculation, Robin. You said a 1 meter square piece of graphene could hold 4 kilograms. I multiplied by that by 20 and got 80 kilograms. So in theory, 20 sheets of it would be able to hold up an 80 kilogram person, which is most people in here wouldn't weigh over 80 kilograms. Multiply that by 2.2 and you get your pounds. So if there were some way to get 20 sheets, a meter by a meter, that would still only weigh only like I'm doing my math on the 20 times, so still about 2 milligrams or so. I mean, it'd be ridiculously low. Let's call it 20 milligrams and round up a little bit. So again, the mass is just incredibly light compared to what it could do and hold you guys up. So the trick might be figuring out ways to synthesize it so you could get a real meter squared and then put some layers together. But really, really, really cool technology, and I think your video did a great job of showing it all very visually. So thank you. Let's give Robin a good round of applause. And we're going to move on to Casey's, whose is very, very similar in terms of nanotechnology, so I think we'll see some overlap there. Casey, yours is a PowerPoint. Do you talk through it mostly, or is it a...
Yes, I will talk through it.
So you'll tell us what to hit and what to push and all that stuff. So I'm going to have mine loaded up, and we'll listen to you live. Could I get thumbs up once everybody's ready for Casey's? Looks like everybody, but go ahead, Casey.
You want me to tell you when to go advance the slide and everything?
Yeah, I think that'd be great to tell us when to advance the slide, and I think you've got a couple things where we hit to see video. Is that right?
Yes.
Okay. Maurice, are you set? Okay. So, Casey, take them away. Thank you.
All right. My project is on nanotechnology, and just a side note, I chose this background very specifically because... not this background. Yeah, this one, because the hexagon's shape in it resembles the Buckminster fullerene that Robin talked about in his project. Fullerenes won the Nobel Prize for Chemistry in 1996, and they're more commonly known as the buckyball, and they're very important in nanotechnology development. Next slide. Nanotechnology is the understanding and control of matters at dimensions of roughly 1 to 100 nanometers. 1 nanometer is 1 billionth of a meter. DNA is approximately 2.5 nanometers wide, and a human hair is 80,000 to 100,000 nanometers wide. So just context for what we're dealing with. I took a different approach to this project. I researched 3 major engineering colleges and what they are doing in the nanotechnology field. Next slide. The first university I researched is Purdue University. They recently built their Burke Nanotechnology Center, and I don't have time to go through all of the research categories, so I'll just hit a few of my favorites. Biomolecular detection is using nanotechnology to detect DNA, RNA, proteins, and small molecules whose presence indicate diseases. Research in biomolecular detection includes developing nanomechanical and optical biosensors to detect proteins such as cancer markers, researching receptor molecules, and integrating them into biosensing using nanoparticles and rapid detection of pathogens, and also enhancing the sensitivity of biosensors. Micro and nanofluidics is focused on experimenting with fluid dynamics that take place in macro or nano domains. Students and professors are currently researching in fundamental biology by testing the response of live cells to flow stresses, and in fundamental fluid mechanics by characterizing microscopic supersonic flows. Computational nanotechnology is using simulations to explore nanoscale structures, devices, and systems. They use a method similar to the Monte Carlo method that's talked about in The Disappearing Spoon to develop physical and computational models to study nanoelectronics, phase change memory technologies, ultra-fast laser manufacturing, and fundamental nanoscale thermal and fluid transport. And lastly, thermal micro nanosystems is using nanotechnology to moderate the temperature of micro and nanosystems.
I'm really, really sorry. We're having a lockdown.
Yeah. Thanks for telling us.
Bye.
Okay.
That's okay. It's going to happen.
They're researching micromechanical electrohydrodynamic-based liquid pumps, and ionic wind-driven heat transfer, film evaporation, carbon nanotubes as a way to spread heat, as well as other temperature management technology. Next slide. When substances are used in a nanoscale level, their physical, chemical, and biological properties begin to differ. The research at MIT is more focused on studying and understanding the changes to the behavior of materials on a nanoscale level than engineering the technology that functions on a nanoscale level. So, nanoindentation is the probing of a sample with a diamond to measure its load and penetration depth of the sample. Nanoscale plasticity is the use of nanoindentation as a way to understand how materials deform permanently or plastically. They measure the loads at which the sample deforms to create, and then they create computer models of the atoms during indentation. And then they take those computer models and use computational simulations of nanoindentation. And they use the Monte Carlo method again and plug in numbers to see what happens. Also, nanoscale magnetic recording media, growing magnetic metals on polymers and polymers on patterned substrates so they can be used as data storage devices. And then mechanical testing of small-scale structures. They have designed machines to test small structures like fibers, thin films, and material available in small quantities because of rarity or cost. So I'm assuming graphene and other materials like that. Next slide. The next college I looked at was Caltech, and they just have categories that their nanotechnology research falls under. They weren't very specific on their website. So nanobiotechnology includes finding new ways to isolate or amplify just a few proteins and increasing biosensor sensitivity to specific molecule recognition. Nanophotonics includes precision geometric engineering, mesophotonic materials and photonic crystals, and research-defined optical circuits that are optimized for confinement and extraction of light. This would provide inexpensive telecommunication and high-speed optical interconnections for data and access in computers. And large-scale integration of nanosystems is a focus on finding a way to integrate the findings from their research into a functional system that incorporates... Oh, yep. Anyways, next slide, please. Okay. So this is a quick example of how nanotechnology can be used in everyday life. Ultra EverDry is a solution engineered to be super hydrophobic. There are 3 super quick video clips of Ultra EverDry at work. It's just to show that nanotechnology does have an application that's not super obscure. So if you'll hit the space bar. and play this video. Go, yeah. And if you, yes, there. One of the gloves had the super ultra dry on it, and the other one didn't. Hit the space bar again, and hit play. He just threw paint on a canvas where some of the canvas had the solution on it, and the other half didn't, and hit the space bar one more time. This video takes place 2 minutes after he throws the paint on it. So, the material works very well as a hydrophobic material. So in sum, nanotechnology is a growing field with major research happening at many renowned facilities around the world. There are potential applications for nanotechnology in medicine, in electrical engineering, in thermal moderation, and ways that probably haven't even been thought of yet. Thank you for listening. Yeah.
All right. Thanks very much, Casey. Margaret, I believe you got the first question up for Casey.
Yeah, great presentation, Casey. I like the way of going through schools and talking about nanotechnology through different institutions. I think that's cool. My first question for you is about applications of nanotechnology. So I was wondering if you know any of the applications of silver nanoparticles, because those are very popular now in a couple of fields.
I did read about it. I'll have to try to remember. It was a while ago. I feel like silver nanoparticles, they have, what was it? I'm drawing a blank. I'm sorry. I guess I don't know. I think I did once.
If you want to spend some time and think about it, I have another question if you want to.
Okay, that would be wonderful.
Ruminate on it. Yeah. Okay. This other question is perhaps even a little bit tougher and perhaps more obscure, because I know you were kind of just looking at general topics. But I was just going to ask, because quantum tunneling becomes a thing when you're working with like the nanoscale, and I was wondering if you could describe in very, very basic terms just what the idea of quantum tunneling is, and if that's like. Just, you don't have to be very technical. It's kind of a simple notion if you break it down, but I was wondering if you could do that.
Margaret, I'm afraid I have no idea what quantum tunneling is.
I'm sorry. I don't. It's just
that.
Something that, like tunneling diodes or something we use in phones, and they're kind of on the nanoscale. So it's just the idea that because electrons are sort of like in a quantum superposition, that they can actually just tunnel through surfaces without actually passing through them and just end up on one side from the other and just move through the wall without actually having physically moved through the wall. They just sort of like end up in a superposition in a different place. Do you want to take another shot at the silver nanoparticles question?
Yeah, I feel like they have something to do with. Does it have a medical application or?
Yeah, kind of. Right.
Okay.
Yeah.
I feel like it would be used.
Very general medical
it would
application.
Have, yeah. I know that silver has a incredible antibacterial properties.
Yeah, exactly. That's basically all I was looking for.
It is? Okay, wonderful.
Yeah, so they like put silver nanoparticles in socks and stuff to get rid of the smell and bacteria and stuff. That was all I was looking for.
Okay.
All right, cool. I'm going to split the point between you guys 1 and 1. Good job. Who else has got questions for Casey about nanotechnology?
Mr. Walker?
Yes, Samvit.
May I ask Casey a question?
That'd be awesome.
All right, Casey, can you please re-explain the Monte Carlo analogy you had, especially what exactly the Monte Carlo method is?
Okay. The Monte Carlo method is mentioned in The Disappearing Spoon, and it seemed to me like they just take numbers and they have an equation and they plug the numbers into the equation to simulate different whatever they need to, really. So in in the disappearing spoon, they were simulating how a specific molecule moves to see if a bomb would go thermonuclear or not. And in this context, they have a computer do simulations of how nanoparticles react and in certain conditions. So under what stress levels they will deform and how much weight it takes to permanently deform a particle of some substance. So that's mainly what I was talking about. Does that answer your question?
To an extent, yes. Thank you very much, Casey.
Thanks, Samvith. Other folks with questions for Casey? Good, Maurice, thank you.
Hi, Casey. So I had a question regarding the medical applications of nanotechnology, in particular, kind of its application to cancer research and cancer treatment. I was wondering if you knew kind of anything more about that.
It seems to me what they're really focusing on with nanotechnology is sensing the proteins that come in cancerous cells. So biosensors are it's a nanotechnology that can go into your body and find specific cancer cells and tag them and target them without targeting other cells in your body, which has been a problem with cancer treatment. So right now they're trying to find a molecule that is sensitive enough to locate specific cells in the body. So that's the main focus right now, I think.
Good. Is that Joel with your hand up? I can't see Dallas Fort Worth.
Yes.
All right. Thanks, Joel. Go ahead.
But, Mr. Walker, can I run to the restroom real quick?
Yeah, of course, Willie.
So you over a lot of different nanotechnologies. What was the one that you thought was the coolest or the most interesting?
They were all really fascinating, and some of them I had trouble understanding, like nanothermophysical engineering. I didn't talk about it, but I actually did research on every topic you see in the PowerPoint. But my favorite was definitely the biomolecular detection, because that seems like it seems like we have a really great need for that in our society right now. So.
Cool. It looks like Chad and then Chandler have hands up.
Kind of a similar question to what Joel was saying. Which kind of nanotechnology do you think humanity has made the most progress on out of all of these?
Most progress, I think, would be from MIT. Yeah. Where is it? They're doing research with how nanotechnology and nanoparticles respond, and the fact that they can make machines that can test nanoparticles seems like a really really large technological jump for us. And also the fact that they can grow magnetic metals and polymers on a substrate and then use that as data storage seems incredible to me. So I found that fascinating.
Cool. Chandler and then Willie, is that a hand up too?
Yeah.
Okay, let's go to Chandler and then we'll go to Willie.
Going back to the micro and nanofluidics that you talked about and how they can create these objects, what are some of the applications of these things that are created from micro and nanofluidics?
The main one that I saw was using microfluidics as supercoolers in different where'd it go? Sorry, technological problems. Using them as a coolant in different technologies. That's all I found from the websites. That's all they were willing to give, I guess. And I think mostly also they were testing like how blood flows and how our cells respond to the stress of circulation. So I really don't know where they're going with that technology, but that's what they've done so far.
All right, cool.
Thank you. Welcome back, Maya. Willie, I think you have a question.
What you said the buckyballs are important. What exactly are they used for?
I think mainly with engineering, the substance, and oh my gosh, words today. I'm sorry. Energy and electrical. Oh my gosh, I'm sorry. Using them as an electrical contact.
Okay, cool.
All right, let's give another hand up for Casey on that one. Good job, Casey. I believe we go to Joel next and doing some cap.
Casey,
Yeah.
I'm just really sorry for interrupting you in the middle. They
Go ahead.
called an evacuation. That's what happened. And so yeah.
No,
Thank you.
Was it a drill or was it a drill or a?
I'm pretty sure it was a drill that I just wasn't aware of. But we've called evacuations for really stupid things before, like there were dogs a couple years ago. So
Better
who knows?
safe than sorry.
Why would you stay inside if there were dogs? Did they get in the building?
They sent us to they sent us, like right now I'm on main campus, but they sent us all the way out there to like the 5th soccer fields, which are like through the woods and whatever else. So.
All right. Well, welcome back. We're going to go on with, can you guys load up Joel's presentation on caffeine, please?
I wonder why they never send us to the 5th.
So let's get some thumbs up when we're ready for that. Olivia's ready. Margaret's ready. Robin's ready. Maurice is ready. Chandler's ready. Maya's ready. And Fort Worth is ready. So we got everybody on the set now. Joel, do you talk through this or is it a presentation through the PowerPoint?
No, I'll be talking.
You'll be talking through the slides.
Yeah.
So if you could just, I'm going to present here and people can watch as well on their own devices, but you just make sure you tell us when to advance slides. Okay.
Right.
So we're ready for you, Joel. Thank you.
All right, so most of us are very familiar with caffeine, and that's its chemical structure in the picture there. And we drink it in coffees or sodas or eat it in chocolate. And in its pure form, it's a white crystalline powder. It stimulates the heart and is a mild diuretic. It stimulates the central nervous system, making one feel more alert and energetic. It is an additive. It is addictive, as many of us know, and one can actually have withdrawals from it. And it may have been used as early as 800 AD, and it's been popular since the 1400s in Europe and Asia. Next slide. And studies by Johns Hopkins University have showed that 90% of Americans consume some source of caffeine every day, and over half of American adults consume over 300 milligrams per day, which is actually like quite a bit. And caffeine occurs naturally in about 60 different plants. The most well-known ones are cola nuts, cocoa beans, coffee beans, and tea leaves. And it's a natural pesticide for the plant, and droppings from the plant infuse the ground with caffeine, making it difficult for other plant types to grow in the nearby area. And it's added to many soft drinks, and each drink usually contains anywhere from 35 to 55 milligram per 12-ounce can. However, the FDA's limit is 71 milligrams per 12 ounces. However, energy drink companies are able to get around this because they don't call their beverages sodas, and so they can put as much as they want in there. And in chocolate, it ranges a lot. There can be anywhere from 3 to 36 milligrams in a 50-gram bar. Next slide. And so this is just kind of like a image to show how much caffeine there is and the typical things that we consume. And next slide. So it's really interesting how caffeine works. After ingestion, it's fully absorbed into the body after 45 minutes. And it's fat soluble and therefore can easily pass through the membrane of any cell. And it depends on the person how long the effects last, but in general, it lasts longer in pregnant women. It takes them longer to break down the drug, and it's mainly eliminated by metabolism in the liver. And it passes easily through the blood-brain barrier, unlike many other drugs. And the effects of caffeine relate closely to the effects of adenosine in the brain. And as adenosine is produced in the brain, it binds to adenosine receptors, causing drowsiness by slowing down nerve cell activity, and it causes blood vessels in the brain to dilate. And the body views caffeine as adenosine, and the caffeine can bind to adenosine receptors, but once it binds to the receptors, no more adenosine can bind to them. And it doesn't slow down the cell's activity like adenosine does. And this explains why one can have trouble after consuming caffeine, can have trouble sleeping after consuming caffeine. And it also inhibits adenosine's ability to dilate blood vessels, and so it constricts them. And this helps with some headaches. And it has an effect on other neurotransmitters in the brain. And it increases the transmission of dopamine. So that improves our mood and may protect our brain cells from age and disease-related degeneration. And by increasing the activity of acetylcholine, caffeine increases muscular activity. By raising and adjusting serotonin levels, it relieves depression and makes us more relaxed, alert, and energetic, and relieves migraine headaches. And since caffeine causes increased neuron firing, the pituitary gland senses this activity and thinks something is wrong, so it releases hormones that tell the adrenal gland to produce adrenaline. And adrenaline opens airways, makes the heart beat faster, increases blood flow to muscles, and it makes the liver release sugar into the bloodstream for extra energy. It makes muscles tighten up. And so it doesn't just affect the adenosine glands, it also affects the body in other ways too, which I thought was really interesting. So next slide. So there are negative effects of caffeine, and the addiction is linked to the increase in dopamine that caffeine causes. And when the adrenaline wears off, this explains the crash that many people feel from caffeine. And Harvard did a study which showed increase in coffee consumption increases the likelihood of contracting diabetes. It also has a very negative impact on sleep in the body. It has a half-life of 6 hours, so even if you sleep, it's not a good deep rest, and not like you don't feel well rested the day after. And so it's easy to see like how a cycle can start where it's just addictive, where the next day you're tired because you consumed coffee the night before, and so you need coffee that morning to wake up, but then you can't sleep well that night because you drank coffee that day. And then you can also build up a tolerance too, adding to the addictive quality. But while there are negative effects, it's considered so safe because a lethal dose for an adult is somewhere around over 10 grams. And there's a lot of websites where you can like calculate how much cups of whatever you'd have to drink for it to be lethal. And so I did that for my weight, and I'd have to consume over 56 cups of coffee for it to be lethal, which that's not even possible. Like, I can't consume 56 cups of water. And next slide.
That would probably be lethal too.
Yeah.
And so there's a lot of medicinal uses for it. And it's used in weight loss pills to boost metabolism. And caffeine that's been treated with potassium or sodium can help breathing in babies or young children.
Stand up.
Yeah, I'm okay.
It's used to kickstart other medicines like aspirin or acetaminophen, and also used with some drugs like ergotamine to treat headaches. It reduces likelihood of developing Parkinson's disease by up to 80% for regular coffee drinkers, and it reduces the risk of developing colon cancer. There's also a possibility of using using caffeine to treat Parkinson's disease, Alzheimer's, and even cancer. But this is still completely experimental, and it's hard because caffeine affects different mammals in very different ways. So it's kind of, we do a lot of testing on rats and other animals, but then when we try and move it to humans, it completely changes. Next slide. So caffeine is the most prevalent drug in the U.S. and many other countries around the world, and the drug affects the brain in many different ways, offering benefits and drawbacks. It inhibits the binding of adenosine and increases production of dopamine, serotonin, and adrenaline. Although it is the most studied drug, its effects are still not fully understood, partially because there are so few people who don't consume caffeine to use as a control group. But there are many tests to try and use caffeine in a variety of medicinal applications and new drugs. And that's it.
All right, thank you. We're going to try to go to Sambit first for the first question. Sambit, if you can hear us.
Mr. Walker.
Yep.
Hi. Okay. I did not realize I was going to be presenting, asking questions today. Okay. I have no questions.
Okay, thanks, Sambit. Joel, 2 points. Who's got a question for Joel? Let's see. Let's go with Olivia first.
I was wondering if you could talk a bit more about the possibility or like how caffeine can increase your chance for diabetes and how that works.
I didn't really look much into how it increases your chance for diabetes. I just saw that there was a study that it did. It's really interesting to me that like it's such there's so many studies that have been done on the drug, but that we still don't really like fully understand how it affects our body because it does so many different things.
Yeah, I have a wonder there. I wonder if it's not the caffeine that's causing the problem with the diabetes. It's the source of the caffeine, which may be a caffeine or a soda or some other, a lot of coffee and bringing in too much sugar, and then somehow that's related to the diabetes risk. I don't know, but I wonder.
Yeah, that's definitely a possibility, and that was another thing that's a problem with the studies is there's no real control group, and then no one consumes caffeine just as the powder because that tastes terrible. So it's usually mixed with sugar to make it taste better.
Willie, I think.
Okay, so when people don't drink caffeine and they're used to it, they typically get headaches and stuff. What are those what is the cause of the withdrawal headaches?
Basically your brain just gets used to having caffeine all the time, and so it constricts the blood vessels in your head, which oftentimes can make a headache go away, which is good. But then when you stop using caffeine after you're very used to it, your blood vessels dilate, and so it can cause a really pounding headache in your head, and so that also contributes to addiction.
Chad, was that you with a hand up?
Yes.
Thank you.
Exactly how addictive is caffeine with respect to other chemicals?
I mean, it's not real addictive. I think part of the problem that it's so addictive is because no one views caffeine as a drug really, and that it's so easy to get it. I've been driving home from school and pass by Starbucks and I have to stop. I need caffeine. And so I've experienced it. I guess it depends person to person, but think about how many people especially teachers, we see them all the time. Every morning they have a cup of coffee or several. And so I think it's not too addictive, but it's so readily available that so many people consume it, and so it makes it seem more addictive than it really is.
Other questions? Maya, thank you.
So like with coffee, my dad drinks upwards of 8 to 9 cups a day of coffee, and he has read studies that he swears by that if you drink more than like 6 cups of coffee a day, it's like more beneficial than if you don't drink coffee at all, or if you only drink slight coffee, which I think he's just BSing me, so I stopped yelling at him. But did you find anything about that?
Well, it does. There are like benefits and drawbacks. So like it would reduce your risk of getting Parkinson's disease, because like it makes your brain very active. But then there's also drawbacks of it, and I feel like especially with sleep, most people wouldn't be able to get very good sleep with that, and that can affect the rest of your body very negatively. But there are benefits of it. I'm sure the studies that he reads just kind of focus just on those.
I'm not trying to cut in, but I did see a thing that was like coffee has been studied and found that it increases heart risk. It's been found that it decreases heart risk. It's been found that it increases and decreases diabetes. That it also lengthens and shortens your lifespan. So most studies on it are kind of go back and forth. That was kind of funny.
Robin, sorry, I didn't see your hand.
So really great presentation. One question I just had is, you mentioned that caffeine is being used in weight loss pills. Could you maybe explain that a bit more specifically? So how it is being used and why it is perhaps so effective?
Yeah. So caffeine, it like basically increases all of your body's functions, and so it increases your metabolism a lot, making you able to burn off calories more efficiently. And so that's just the main reason that it's used in weight loss pills, is so that your body's more efficient at burning calories.
Casey.
I was just wondering how long it takes for your body to become accustomed to caffeine. Like, how long does it take for it to stop being effective or affecting your body in a normal way?
Like, are you talking tolerance?
Yes.
I think that's really dependent on the person, because caffeine affects people in very different ways. And so I think tolerance is really more based on the person themselves. And then most people that are big, I'd consider coffee the biggest source of caffeine. Most people that are big coffee drinkers kind of have like a routine. They'll drink like 2 or 3 cups, and like, so they're used to it and have kind of a schedule. Most people don't like keep trying to up the amount of caffeine that they're taking in. So I'm not really too sure how long it takes to build up a tolerance.
Okay, thanks. Margaret, was that a question? No.
Mr. Walker?
Some bit.
I have 2 questions, if it can count for anything whatsoever. My first question is, could you please clarify what adenosine does again?
Alright, so adenosine, it binds to adenosine receptors, and basically its job is to like make the body tired. It helps a lot with sleep, so it dilates the blood vessels in the brain, and then it also decreases brain activity. It like slows it down to help your brain, like to help your body start resting and help you relax. And so caffeine kind of like does the opposite of all that, because it inhibits adenosine binding to the cells.
All right. My second question is, do you know if any studies have demonstrated that caffeine as a stimulant can lead to an addiction to other stimulants? Since you mentioned that caffeine does have a low addiction potential.
No, I didn't look at any studies pertaining to other stimulants.
Okay.
Thank you. Let's see. Joel, did you see anything in terms of which animals are negatively affected by caffeine other than humans? You mentioned that a little bit about animals.
No, I didn't read too much on the effect of animals.
I just know my dog got into some chocolate one time, and it was a bad scene. So you guys know to keep chocolate away from your dogs, and I think it's the caffeine inside it that causes the problems. Let's give it up for Joel. Good job, Joel. Joel, what got you excited about doing caffeine as a project? Are you addicted?
Yeah, I like coffee. It's kind of bad. I try and not drink it unless I need it, because then, like, if I drink a cup of coffee and I, like, haven't had any caffeine, like, in a couple of days, I, like, really get going. I'm going for the rest of the day. And I also think it's cool how it's, like, a drug, but no one really considers it as a drug.
Yeah.
And because everyone consumes it.
Yeah. Let me get you guys to do two things for me. First, I'd like you to go to Google Docs and search Element, and I think you'll see this shared Google Doc, MSON Element Project 15. Can you guys log into that? And I'm going to see if any of you already know a favorite element. I'll suggest some. There's some awesome elements out there like lead, aluminum, tungsten, gold, sodium, chlorine, xenon, radon. Amazing elements out there, and give you a chance to take a shot at choosing one. There's probably not an element you couldn't find incredibly fun things about. Boron, certainly nitrogen, world-changing elements, sulfur. Carbon is so big, this whole class is on it. So maybe carbon's a little too big, but you could potentially try hydrogen or helium. Pretty amazing. Uranium, chromium, copper, titanium. Lots of fun elements out there. I shared zirconium. There you go. So I don't know if you guys have a sense of a fun element that you'd like to learn more about. I'd hope you'd pick one you didn't know terribly much about. But once you grab one here, it's yours, and I would encourage you to go ahead and, if you know, steal one. I got no biters. Nobody's grabbing an element. Hey, we got titanium taken. Nice. Anybody else? You got a little time to decide, but you're gonna do some. Joel's got helium. We're gonna do some research on an element. This is not. You're not gonna make a presentation. You're only gonna put your research in a Google Doc. I am gonna ask you to do a little creative writing. So I sent you that. You can write as though your element is a human, or you could write in the style of Sam Keen. Might be another fun thing for you to do in terms of your element. So anyway, that's there. Or did I just scroll out of it? No, there it is. Somvith, if you yell out an element that you're interested in, we could write it in the Google Doc for you.
Mr. Walker, I would be interested in magnesium, though that's not final.
Okay. All right, I put magnesium with a fear of commitment there for you, no problem. And yeah, we've got other people with some question marks, so that's fine. And so anyway, you guys can think about that, have some fun with that. Can you also open another Google Doc for me? This is the one that is titled YouTube suggestions. So if you search under your Google Doc for YouTube, Y-O-U-T-U-B-E, you'll find that one easily. Chad, you had some things on here that it looks like are now gone. I thought you had more than just this one.
I think I just had, is that the Vsauce video?
Vsauce, yeah.
Yeah, that's the only one I put down so far.
Okay, so Maya's
I think my notes were on Chad's page, the one about the ant hill.
That's what happened. Okay, gotcha. Now Margaret's got about 8 videos for you, or 7 videos for you guys to look at. Robin's got a few. So these are what folks have found. Maya's found 4. So there are tons and tons of these out here, and especially if you've already done your project presentation, I'd love to see you out on YouTube finding some fun chemistry videos, giving us a sense of what they're like. I really mean for this to be fun, but I see that some people aren't having any fun or joining in on the fun. So just in terms of, well, we're running out of time, but you've got to start working on your element. And also I want you guys to actually be coming up with your own demo, and we'll talk about that a little bit in our next class. But I want you to demonstrate something chemically, and I want you to kind of make it almost like a little teaching lesson. So I don't want you to just demo it. I want you to talk a little bit about what it is, why it worked, how it worked, something like that. Make it a teaching lesson. It can be on the shorter side. I want you to have fun with that. So it can be, as long as it's done safely with an adult, either at your school or at home. It can be an explosion of some sort that's controlled and contained. It can be, something as crazy as thermite reaction, which is probably the most exciting exothermic reaction out there. If you do it right and safely, which is outdoors, away from anything, at least 10 yards around, then it's a really fun reaction. But anyway, I'll need to approve those in terms of safety and other things, but I want you guys going on that. I will see you. This is Monday. I will see you guys Thursday. Take care. Great class. Extra credit for Maurice and Chandler for coming in on Senior Skip Day. Yeah! Woohoo! All right, goodbye, everybody. Somebeth, you get Somebeth extra credit for logging in from a bus in Florida. Good job.
Well, I'm not on a bus per se. I'd also like to apologize for not having questions ready. That's my fault.
Okay, that's okay. No problem. Bye, Rob.
Thank you very much, Mr. Walker. Bye.
See you later, Mr. Walker.
Bye, Somvit.
Bye.